So today let's make another episode of dodgy USB phone chargers, and maybe one good one for comparison. This one is from eBay and the other one I don't remember exactly. I think it was donated, so big thanks for the donation. I just randomly grabbed two pieces from my box of dodgy USB chargers for a review. This one definitely looks questionable at first glance because this European plug is not actually a proper European plug. It can fit a type F socket probably, but not type E socket. This one does not fit. This one does. And also in a proper 2-pin flat European plug, the pins are not straight. They should be slightly converging. They're converging in this one, but they're straight in this one, which also gives a clue that this one might be a horrible electrocution house burner. This one might be good. This one has quite a vague marking, just some type number, the input voltage, universal mains, the output 5 volts, 1000 milliamps or 1 amp. This one has more markings on it and it's the same output rating, 5 volts, 1 amp. But of course the rating doesn't mean that it actually can supply the current, and I have to use a dodgy travel adapter to test this one, and it can't actually supply 1 amp. When I go to about 0.86 or 0.88, it shuts down, or the output voltage drops too low for the tester. The other one can fit my socket and it also can supply 1 amp, or a little bit more than this. It's shutting down at about 1.2. Just out of curiosity, let's try to weigh them. The good one, or good looking one, is over 35 grams and the questionable looking one is barely half of it. This one is suspiciously lightweight. Now let's see what happens if I leave this one running for a bit longer at the maximum current it can supply, which is actually less than what it claims. 5 hours of continuous operation and no failure, but still shuts down at about 0.87 amps, and it's quite hot. I can keep my fingers on it, but it's quite unpleasant. But now of course let's open it. Let's pry it open, which is easy. Here is the plug and here is the board. It smells of plastic and circuit board material getting very hot. Here is the bridge rectifier, the chip on the primary side, a couple of resistors, some diode, and the rectification diode on the secondary side, some discharging resistor for the secondary capacitor. Here is the primary smoothing electrolytic capacitor, some auxiliary electrolytic one, and this secondary one. Here is the transformer, quite tiny one, the USB port, and this capacitor, 3.3 nanofarads, between the primary and the secondary side. This one is meant to suppress the common mode interference getting to the output, but a capacitor between the primary and secondary side should be a safety one, but this one is not a safety capacitor. The board actually says CY, because it should be a class Y1 safety capacitor, but it's not, and this one doesn't even have a voltage rating on it. This makes it quite questionable, and the isolation distance between the primary and secondary side is quite huge here, but here it gets quite narrow. Here it's a bit better again. At this point is the worst one. This is on the primary side and this is the USB port. The isolation distance is about 1 millimeter. Here's the marking of the chip if somebody's interested. And of course the mains goes straight into the bridge rectifier with no interference filter, no fuse or fusible resistor, no inrush current limitation. Now of course let's desolder the transformer and make an autopsy of it. Removing the sticky tape. And this thing already looks questionable to me. Unsticking the ferrite core using my molten hair dryer. The core opens. The corner of this is broken. I didn't do it. Now let's remove the sticky tape. And this is going to reveal the safety of this transformer, and yes, it's one of the worst ones. There is absolutely no insulation between the windings. This thick primary is mixed with the other windings. This thin one, which is probably the auxiliary, which is on the primary side. So basically the output of the charger is isolated from main as just using the lacquer on this wire, which is about 0.00 something millimeters thick, and it was never meant as a safety isolation. The lacquer on the wire is never meant for applications where its failure can cause an electric shock. The auxiliary is on top, the secondary is under it. And the secondary seems to be isolated using a sticky tape from the primary, but it doesn't help because the auxiliary winding was also connected with the primary side, and also there is a gap in the insulation. The insulation on the primary has a gap, and also the ends of it are exposed, and the secondary can touch it. Scratching the secondary, and it seems to be copper, not copper-coated aluminum, which kind of surprises me. But of course with no fuse or fusible resistor for fire safety, poor isolation distance between the primary and secondary side on the board, and this questionable capacitor, and just about no insulation in the transformer, the conclusion has to be super dodgy. And now testing this one at its full current, it still works well after 4 hours, and the temperature is significantly lower. This one is just warm. But now let's try to open it. This one doesn't seem so easy to open. Let's just halve it using a saw. And that's it. This is really not meant to be opened. And here's the circuit board. And this one seems much better built. It has this fusible resistor at the input, this bridge rectifier, then 2 primary smoothing electrolytic capacitors with this inductor in between. This inductor is between the positive terminals, and there is some super tiny inductor here between the negative terminals. This is the interference suppression. There is again an auxiliary capacitor on the primary side, and these 2 capacitors in a series between the primary and the secondary side. They are 2 in a series for redundancy, for more safety, to make it even more unlikely for the primary mains voltage to get to the secondary side. And they are probably both class Y1 capacitors. Good capacitors, just the laser marking is annoying. And here's a much bigger transformer than in the other one, the USB port, and the secondary capacitor a bit bigger too. Here's the bridge rectifier, the switching chip, some capacitors and resistors, the secondary rectification diode, some discharging resistor for the capacitor probably, a 0 ohm jumper between the data pins, and of course a huge isolation distance between the primary side and the secondary side. And the primary capacitors are a pair of 4.7 micro ones, versus just one 2.2 micro in the other one. The secondary capacitor also more capacitance than the other one. And now the transformer, this is the primary and auxiliary, this is the secondary, and the secondary leads are extended farther away from the other windings before they go to the pins for more safety. Some marking on it, 1.6 millihenry. In this tester it says 1.48 millihenry, but now let's disassemble it. Here is the extended part with the secondary pins, and let's open the core now. And the core has this connection to remove the high frequency voltage that's capacitively coupled to it to reduce the interference radiated from it. Now let's remove the sticky tape from the windings. Here is the sticky tape and the secondary under it, and also a piece of tape separating it from the primary or auxiliary pins. This is good for extra safety. And the secondary is not a normal transformer wire with just a thin lacquer on it, like in the other one. It's a safety thick insulated wire with probably more layers of a thick safety insulation on it. 2 or 3 thick layers of insulation versus 1 super thin lacquer. And even with all the insulation on the wire, it still has this tape, further insulating it from the other windings. And the autopsy of the wire, I stripped this transparent insulation from it, and there is another yellow insulation on it. Transparent insulation and yellow insulation. And maybe also a lacquer under this. And this tape insulating the secondary from the terminals of the other windings. Plus this tape. 1 turn, 2 turns. And then there is this. It's not a winding, it's probably some sort of interference shield, a loose spiral of a wire with one end not connected. This reduces the capacitive coupling of the interference into the secondary. It's under another layer of tape. One end is loose and the other end is connected to one of these primary side pins. A pin with just a DC voltage on it and no high frequency voltage, of course. Probably the positive or negative of the rectifier mains. Then another insulation. And this is probably the auxiliary winding. Some tape and finally the primary. This one of course has the most turns. And there is one oddity, the core halves are slightly different sizes. I have no explanation for this. So this one is much better with a fusible resistor for fire safety, some interference suppression inductors, and also some features in the transformer for interference suppression, a huge isolation distance on the board, plus 2 safety capacitors in series for even more redundancy, and the transformer has 2 thick layers of insulation on the wire plus some tape between the windings. And unlike the other one, it can actually supply the current it claims. The box definitely doesn't open by accident, and it's definitely not getting as hot. So the conclusion is... nice! So that's it, and please consider supporting my channel on Patreon or using the thanks function. And big thanks to all of you who already support me. And I plan to explore what's inside of this synchronous scope.